Okay, I'm going to skip problem number 12 because I have already given the answer. There is nothing much to do except to arrange them into different categories. So I'll skip that. There's no computation involved in that problem. So we'll go to problem number 13, and here we have means are given for there is some plaster of Paris containers of 32 ounces, and samples were taken 6 boxes at a time. So each sample contains 6 boxes, and the mean and range for each sample is given. So n is 6 here. Okay, we must remember that. Now the x bars are given, r's are given. I've already written them down. So we have to find x double bar and r bar, and for that we have to first sum. Okay, this sum is 341 and this sum is 5. So x double bar is 341, so this is sum of 10 numbers. Okay, and r bar is 5 over 10, that is equal to 0.5. Okay. Now to construct the control charts, we need, so from table S6.1, so for n is equal to 6, we need to find the a sub 2, d sub 3 and d sub 4 values, and from that we can set up the control charts. So here is the table. Okay, n is 6, so 0.483, 2.004 for d sub 4 and 0. So 0.483, d sub 3 is 0 and d sub 4 is 2.004. So control chart for x bar is x double bar plus or minus a sub 2 times r bar. So that will be 34.1 plus or minus 0.483 times r bar is 0.5. So lower control limit of x bar is 34.1 minus 0.2415, and we get 33.86. I've rounded it down to 2 decimal places. These are in 1 decimal place anyway. And upper control limit is plus 0.2415. That's equal to 34.34. Okay, next is R chart. And lower control limit for R is d sub 3 times R bar, so that is 0, d sub 3 is 0. Upper control limit for R is d sub 4 times R bar, so that will be 2.004 times R bar is 0.5, and that gives you 1.002. Okay, now technically we have to now plot all of these values with lower control limit and upper control limit. We'll skip that part, and what we need to find is whether the process is in control. So let's look at the limits. So the x bar limit, okay, and compare it against these. Okay, so this is lower control limit. Now this one is smaller than lower control limit. So X bar for samples. So the first one is outside. Okay. The second one is outside too. Okay, so upper limit. Second one is above the upper limit. Third one is above the upper limit. So 1, 2, 3. And then the rest of them are okay, except here again, like the first one, like the first 33.8, this is again outside. So and 9 fall outside the control limits. Therefore, the process is not in control. Okay. Now let's look at range. Now range is 0 to 1.002 and they all fall within the control limits. Okay. All values fall within the control limits. But that doesn't matter because X bar is not in control. So the process is not in control, and we have to investigate why that is so. What are the assignable causes that must be identified and removed?